Uh, Good evening, everyone who has joined in. We'll be starting the webinar right now. Before I hand over the session for the introduction, couple of instructions. One, there is a chat box below where anything, if you have any technical related issues, you can start to post there. And there's a Q&A box below where in case of any question answers, you can please post it there, which will be subsequently checked with the speaker at the end of the session. I request Dr. Vijay Raja to please introduce the guest and welcome everyone to start the webinar, please.
Good evening all. I am Dr. K. Vijay Raja, Professor in the Department of Aeronautical Engineering.
Sir, you can be a bit loud. Your voice is too low, please.
Okay, sir. Good evening all. I am Dr. K. Vijay Raja, Professor in the Department of Aeronautical Engineering. I welcome all the participants and the faculty members for this today webinar. First, I would like to welcome Dr. Punita Kumari, Senior Research, Wuhan University of Technology. She is going to give a lecture on composite materials and industrial application. I hope it may be very useful for our students, especially for third year, those who are studying composite materials. And moreover, the final year and the second years, it was very useful. The current technology, almost all the aircrafts nowadays we are using the composite material because lightweight composite material. Earlier they may use for aluminum alloy and wood. To compensate that one, weight reducing. Nowadays almost all the modern aircrafts are used by composite material. So I hope Dr. Punita Kumari is going to give a very good lecture using his research idea, and whatever she has did the research in the composite material, it may be very useful. He is from Wuhan University. I hope that Corona came from the China. She may really have the idea how it came. That also one point, it may interesting one. But anyhow, Dr. Punita Kumari is going to give the lecture. I hand over the session to Punita Kumari.
Sir, sorry to interrupt, sir.
Yeah, introduction.
Yes, sir. Thank you. Indeed, it's a great pleasure for me. I'm Venkat from Department of Aeronautical Engineering, KCG College of Technology. I'm honored to introduce Dr. Punita Kumari, a young and energetic researcher. Reading her profile will motivate anyone who just have a glance of the achievement she has made. To start with, she has completed a bachelor's in Tech, Chennai in the year 2013 with first class distinction, master's in aircraft maintenance engineering at our own parent group of Wuhan University at the year of 2015, and PhD in material science and engineering at Wuhan Institute of Technology in the year 2019 in first class. And there are more number of achievements to make. Starting from school, she was the second district level and has got a distinction in Maths and Science and distinction in Maths and Chemistry in HSC, and outstanding contribution to the university certificate in the year 2017, an international award to make a note of, and speaker in a doctor forum experiencing China's Smart Wuhan University at Wuhan University year 2017. And I wonder, in this young age, she is also a reviewer of 4 journals: Polymer Science, Composite Materials Journal, Advances in Science and Technology and Engineering Systems Journal, and MDPI Materials Journal. And she has also got memberships in ASTM International. She has published various number of articles and research publications. It's a honor to have you here, being in this pandemic. I hope you are safe. I was told by Ashish, our faculty Ashish Chandramoli is a classmate of Dr. Punita Kumari. He has told, so due to some technical difficulties, he was unable to join us. His mic is not working properly. Okay. He has told me that you are safe here in India. Glad to have you, ma'am. Please, the session is yours. And as the host, Mr. Pawan has informed, Participants, please put your questions in Q&A sections. Your questions will be answered by the speaker whenever she gets time, or might be in the end of the session. Thank you as of now. I give the control back to Dr. Punita Kumari to host this session. Thank you.
Thank you very much for this much long introduction. I am still the student of Wuhan University. Thank you very much, Vijay Raja sir and Venkatan Raman sir.
Dr. Punita, your screen, I think it is not visible.
Yeah, it's not.
Yes.
So today I will be giving lecture about composite material and industrial application. So in the introduction, we first the definition. What is a composite material? It is blending of the two or more material at a microscopic level. If I say microscopic, thus make it different from metal alloys. And here the two material, that is matrix and the fiber. The matrix is holding the fiber together, and the fiber, it provides stiffness and the strength to the structure. So that is a common example of the composite material, a common definition of the composite material. And history of the composite material, when we have started using the composite, that initiated in 500 BC. In that time, human, they have built their homes as a civil application. They have used mud and straw, and later on, they have made a bow that is made of a wood, bone, and animal glue at 1200 AD. In 1946, that's the first time when the composite material came in the commercial application. In that time, first the composite board that is made of the glass fiber has introduced. That's the first time. Composite material have several advantages that makes the composite material different from the metals or metal alloys. This gives high strength, high stiffness, high toughness, high corrosion resistance property, high wear resistance, chemical resistance, good environmental condition, and high fatigue life, thermal insulation. So there are several advantages of the composite material. Apart from these advantages, composite material also have several disadvantages that is listed here. The tooling, like drilling or making holes or any kind of CNC operation is very difficult in the composite material. Any hidden defects is very difficult to inspect, and they have skilled people to do those kind of job. That's the job called non-destructive testing, and they need very skilled people to conduct those kind of testing or the inspection. These inspection requires special tool, and the composite material raw cost is very high. It's hazardous. It's not reusable. Also, that's one more problem. And there are, apart from this, there are several environmental issues also. If you are using carbon composite, so you need the prepack that's made of the carbon fiber that need to store in the frozen places. So that's also very expensive. So it's not cost effective at all. It's also required extreme cleanliness, because when you're doing manufacturing of the composite, if any dust particle go inside in the manufacturing or in the fabrication, it will degrade the strength or the stiffness of the composite. And the composite material, the product is very brittle, so it's easily damageable in some cases, such such as the carbon fiber, is very literally we use alone carbon fiber. And analysis is very difficult for the heterogeneous composite material and the orthotrophic. So that's also one major disadvantage of the composite material. If you do the analysis of the unidirectional or the open fiber, it's easy apart from the orthotrophic composite material. The applications. So recently, the composite material has used in the construction, that is 16%. Electrical and equipment is 16%. Pipe and tank is made by 12%. Aerospace is 15%. Wind energy is 14%. So this is the market share that is provide the data in the composite material field. In the aerospace industry, composite material is used very widely. Like 53% of the structural part of Airbus A350 is made of the composite material. Airbus has chosen this material because it's very lightweight, and they have conducted one survey in that they have found like uh, it reduced the fuel cost consumption 16% per passenger compared to any other aircraft. So that's one major advantage of the composite. If you are using composite material in the aviation field. Apart from this, in 1940s, like after 1946, the composite material was used in the radar drones. After that, it has been using in the vertical tail and elevator. As the time passes, it's used in the secondary structure such as radar, trailing edge, and the leading edge of the aircraft. So, I'll add just mention here as when the year passes, the application of the composite in the Airbus is increased. So now it is 53%. Maybe in the coming year, it's like 70% or 80%. So that's give very big idea how we need to learn and why we need to learn about the composite material and its application, and why we need to conduct lots of research about the lightweight and the fuel consumption, because the market is very big for this composite material. In aerospace industry, if I talk about India, the Tejas aircraft, the combat aircraft made of the composite. Kevlar composite is used in the nose cone, and the glass fiber composite used in the tail fin, and the carbon fiber is used in the fuselage and the wing part of the aircraft, apart from the control surfaces of the wing. And in the helicopter, Indian helicopter Durga, that is also made of the composite material. Carbon fiber composite is made of the rotor blade, and the tail rotor, vertical fin, stabilizer, cowling, radome, doors, cockpit, that was made of the composite. So these are the two best plane we have that is made of the composite material because of its lightweight and the high strength. So apart from this, in aerospace industry, composite material also used in the missile and the vehicle launch. In the missile nozzle, that's nozzle part, igniter, and the equipment section, and the rocket motor case, that is made of the composite material, whereas the launch vehicle rocket motor case, payload fairing and the dispensers, high temperature nozzle cone, control surfaces, those part is made of the composite in the launch vehicle too. In railway and the sports industry, the body of the railway bogies, including seats, driver cabin, door, gear cases, are made by composites. And if I talk about the sports equipment, there are lots of things made of the composites, such as tennis racket, golf clubs, baseball bats, helmet, ski, hockey sticks, and fishing rod. This kind of the sports equipment are made of the composite material. In the automotive sector, composite material is used in a drive shaft, fan blade, spring, bumpers, interior panels, tires, brake shoes, clutch plate, is kit, hoses, belt, and engine part are made of the composite, including caps, radiator caps, air filter housing, and in structure, skeleton structure, walls and panels, door, window, ladder, staircase, cooling tower, bridge, decks. These things are made of the composites. In industry, conveyor belt, hose, puncture resistance fabric, motor bends, ropes, and cable are made of the composite. In medical too, there are several things that are made of the composite, such as wheelchairs, hip joints, heat valves. Dentists they used epoxy resin. That's not health hazardous epoxy resin. Those people they filled between the two teeth, so they use epoxy resin. And surgical equipment is made of the composite material. If I talk about the electronic equipment, chips, the electronic chips that made of the composites, electronic packaging material, uh, such as stay foam, and there are several kind of things are made of the composites. If in the military side, helmet, waterproof vests, impact resistance vehicle, lighter and the less deteriorable ships, portable bridge. These things are made of the composite material for military application. In marine, ship, boat hulls, instrument panel, hydrofoils, overcraft, propeller, propulsion shaft, radar, heat exchanger, flywheels are made of the composite. And wind power engineering, rotor blade, including blade shells, webs, spar or box structure, generator housing. These things are made of the composite in wind power energy. So these are the several examples that inspire us to learn and do more research about composite material and its to do more applications in the industry. So based on the matrix and the reinforcement, composite material are classified into two types. So first I'll talk about the based on matrix. So composite material are classified based on the matrix are three types: ceramic matrix composite, polymer matrix composite, and metal matrix composite. Polymer matrix composite again has two types: thermoplastic matrix composite and thermosetting matrix composite. I will discuss these two matrix composite in my next slides. The other side, when we classified composite based on the reinforcement, again it has three types: fiber reinforced composite, particulate reinforced composite, structure composite. Then structure composite, they have two types: sandwich composite and the laminate composite. Other side, the fiber reinforced composite has three types: continued fiber composite, short reinforced composite, hybrid reinforced composite. Each this type of composite again classified into two kinds. So first, continued reinforced composite has unidirectional composite and bidirectional composite, and the short reinforced composite has aligned composite and random composite. Hybrid composite are classified into two types: oblique composite and the orthogonal composites. What is the purpose of reinforcement in the composite? It carries the load and transfer the strength, stiffness, fiber to the matrix. So that's the main job of reinforced material in the composite. For example, there are several reinforced materials. For example, carbon reinforcement, glass reinforcement, alumina reinforcement, and the admin reinforcement. In matrix those material that holds the fiber together and it transfers the load uniform between the fibers. It also provides a protection to the fiber from environmental effects, and it gives the good finishing product after the manufacturing. There are several kinds of matrix available in the market, such as epoxy resin, vinyl ester, and the plastic resin. In this is the general diagram I have plotted here. What is it? Reinforced and the matrix. So, white part is shown as a matrix here, and the blue part is shown as a reinforcement. So this long wire, that's reinforced fiber here. This is all the fibers that is unidirectional and is continuous. So that's why this kind of composite is called a composite fiber composites. Other side, when you cut the fiber in small pieces and embed in the matrix, that's called short fiber or short fiber composites. This is the second one. And the third one, this is the composites. It's not round one. It's made the powder of the fiber and it's mixed with the matrix and it's manufactured. So this type of composites is called as a particulate composites. So based on the shape, there are several kind of fibers also available. The circular shape fiber, such as glass fiber or the carbon fiber. Elliptical shaped fibers, that's example alumina. Triangular shape, example silk or silicon. Hexagonal shape is sapphires. Rounded triangular shape and kidney beans as carbon. Tribal shape, that's again carbon. Carbon fiber, they have several kind of types and different kind of shapes also. As I said previously, the difference between thermoplastic and thermosetting matrix I discussed here. The thermoplastic is not permanent based matrix, whereas thermosetting is permanent based matrix. In thermoplastic, when you apply high pressure or high heat, it can deform or soften. So you can again remold this kind of resin or the matrix. Other side, the thermosetting, if you apply more heat or more pressure, it will decompose and it's very difficult to remold that, or it's impossible almost to remold again those kind of thermosetting matrix. The thermoplastic, it's easy or it's easy to repair. Other side, thermosetting plastic, it's very difficult to repair because you cannot provide more heat. If you provide more heat, it will get melt or it will change the shape. In thermoplastic, it has shelf life, infinite shelf life. Other side, thermosetting, it has limited shelf life. So after a certain time, you cannot use thermosetting matrix. The thermoplastic is easy to handle, whereas the thermosetting is very difficult to handle. The manufacturing process of the composite material, there are several process or methods by using that the composite material can be manufactured, but I have listed few that's important. So wet and hand layer, spray layer composite, autoclave curing, filament winding, manufacturing process, polystration process, and the vacuum assist resin infusion method. First, I will discuss about the wet and hand layer method. So in this is the mold. This blue color is mold. It can be any shape or it can be flat table. First, we need to clean the table so there is no any contamination or the dust particle will be there while doing manufacturing. If any dust particle is there, it will affect the stiffness and the uniformity of the composite. So we need to remove any kind of impurity before manufacturing. Then apply the gel coat. The gel coat up is applied because it's easy to demold the composite when once the curing process has done. Then apply the fabric of the fiber, whether you want glass fiber or the carbon fiber. Then apply the resin. Then use the roller and make it uniform. The resin it should be uniform. Then apply again the fabric, the fiber fabric, based on the thickness. How much you want to give your thickness of the composite, you can make the layers like 15 layers or 16 layers or 20 layers. It depends upon you how much you want thickness. You can make it, and after that just leave for like 12 hours or 24 hours. It depends upon the resin curing time, and this resin curing time is given by the manufacturer, because they know like when the chemical gets cured. So there are several advantages and disadvantages of this hand layer process too. The first advantage, the whole process is done at the room temperature, so it's very easy to handle. It's simple, low cost also. Any kind of fiber and matrix can be used in this process. And the disadvantages is when this side, the mold side, the surface of the fabricated composite is very smooth, while the other side, the surface of the fabrication is very rough. So that's one disadvantage. And this is the open process. There is no any covered thing is applied. So this is the open process. So that's also one of the major disadvantage because it's hazardous. And we need to make the resin uniformly distribution in the fabric. So we need skilled people who has experience at least 3 or 4 times to do this kind of work. They can do very easily. So this is the again one more disadvantage. Application of this process, this kind of manufacturing is used in the wind turbine plate, board, and any architectural molding. The another one is spray layer. In this process, this is the port here, port of vessel. In this is the fiber spool, and again the resin is applied here. So one nozzle it has the resin, another nozzle it has the fiber, and it's like chopped fiber. It's not continuous fiber. So first the same thing, we need to clean the surface, then we need to apply the gel coat, and after that we need to just make the uniform deposition of the matrix and the fiber on the mold, and leave it according to the manufacturing guidelines. And after curing, you can take it out. The major advantage of this process is it is easy, and it's very cost effective. On the other side, again the same problem we are getting it, like the this mold size, this mold side is again it's very smooth, whereas the other side it is very rough. So the same again process, same problem again we are getting it here. And there is one more disadvantage. It's very difficult to control the fiber and the resin volume, because the nozzle it will spray the same amount of fiber and the resin at the same time. So it's very difficult to control, and also we need skilled people to do this. If we want it should be uniform. And there is one more disadvantage in this. If we want to acquire like one dimension, like 1 millimeter, but we cannot control this resin code. So we need to do very carefully deposition on the surface. So that's also one more disadvantage of this process. Application of this process is carbon bodies is made by this process, spray layer, and the bathtub also made by this. Shower tray is also made by spray layer. The autoclave curing manufacturing technique. I'm very familiar with this process because I have done my thesis on this process. This is mainly used in the aerospace and the automobile part. And there's first we need to clean the surface. That's very important for all manufacturing. Then apply gel coat, then a breather coat. And the breather coat, we need to assemble all the fibers. It depends upon your or which orientation you want to give the fibers. Like if you're using unidirectional, so it depends upon the orientation which you want to provide. And after that, cover it with again the peel ply or the breather cloth. And after that, seal the whole setup with the vacuum bag and create the vacuum inside the food setup. So in this photo, this is the this is the pump here, and we need to put the whole setup in the autoclave. So this is the autoclave, it's the autoclave door, and it has like big assembly. So this autoclave has pipe. It's connected here to this vessel. Again, it goes another side. I cannot show you the back side of my lab. And after that, carbon, I have used carbon prepaid, and according to the manufacturing guidelines, they have give a certain like temperature and the pressure. We need to cook at that time for that certain pressure, otherwise it will get spoiled. So that's we need to keep in mind if we are doing autoclave process. And the advantages of this process, only large component is made by autoclave, and it's provide very smooth surface compared to hand layer and spray layer, and it's a slow surface. That's also one more advantage. It's not that much hazardous as spray layer and the hand layer. The disadvantage of this process is the initial cost is very high because you need to put the autoclave setup, and it's very expensive. And the running cost also very high because you need to run the whole machine for 7 to 8 hours. Sometimes if you are making like more component, so it will take around 24 hours too. So it depends upon the carbon fiber quality and where and the size also. So it need that much electricity and that much pressure to generate electricity. So it's very expensive too. And you cannot make the small product such as we are using hand layup and the VARI to make the small product. So that's one more disadvantage. And the application I already discussed is used in the aerospace, automobile parts, and bumper for the car. And this is the filament winding. In this process, the cylindrical tube is used that's made of the any material. In my lab, that's made of the ceramic, and it's coated with the gel, and that's called Montreal actually. So this thing is called Montreal, and it has one storage. This storage that's filled with the resin, and this is the fiber layer, the fiber layer, and it just passes through the resin. And when the wool and the fiber wool and the resin gets mixed, and this content it rotates. So it's controlled by machine by computer software, and you need to fit some program to you want this kind of wooden shape or you want any other shape. So that's a disadvantage because whenever you want to use different design, you need to program. So that's the disadvantage of this process. And another disadvantage is uh, towards the mandrel side, the surface is very smooth, and outside is very rough. So that's also disadvantage compared to same as hand layer process and the spray layer process. The advantage of the filament pointing method is the resin content is used that is very controlled, and the fiber is used as also very controlled. It's very fast process. Like if you want to make 1 meter big pipe, it will take around 1 hour or 1.5 hours. It's economical because it's take very less time. And disadvantage, as I said, like this rough product, that's disadvantage. And there's very one more disadvantage, that is only convex shaped component can be made or cylindrical surface can be made by filament winding. And this kind of manufacturing process is used to make pressure bottles, rocket motor casing, any kind of chemical storage tank, pipeline, and the gas cylinder. Sorry. The another manufacturing process is flustration. So in this, the fiber pool is kept here, like 1, 2, 3, 4, 5. 5 pools is kept here, and it passes through the preheater. So fiber it gets heated, and the resin is poured down here. So now its composite is ready, but it passes through again heater. So it will cure the whole composite again, and after that the hydraulic mechanism, it pull the whole thing and it cut it, the saw is there and cut it down, the whole thing. So this kind of fabrication process is very good and very fast, and it's very economical if you are doing mass production. Otherwise, it's very expensive. If you're doing mass production, it's very easy. The resin and the fiber content can be controlled, and the wastage can be minimized. The disadvantage, if you are using only the plain surface or the plain fiber, the plain composites is easy. But if you are using dye, any kind of dye or any kind of molding, so then again it is very expensive to use this kind of process. The application of this is used in the beam and the rider, the ladder, bridge, and the framework. Mostly this kind of manufacturing is used for the civil workers. So this again one method, vacuum assist resin infusion method. This method I have used in Wuhan University, and I think still the pump is there and the whole setup is there. So in this, the mold is there, and we need to clean the surface, apply the gel, and the breeder cloth, and the fiber assembly should be there. Then apply the breeder cloth, and after that, this is the green mesh. Why we need to apply mesh? Because it provides the and it regulates the resin flow towards the direction of fibers. And after that, we need to place the two pipes opposite direction. So one it's create the vacuum, and another one it's flow the resin, and it needs to be opposite. Otherwise, if you keep the same direction, the resin and the vacuum, it's just generated at one side, so it won't reach to the another side of the fiber. It will just half fill. So the thing we need to keep in mind, if we are using a vacuum assist resin infusion method, one pipe should be against another one. Advantage of this material, since the vacuum is created, so there is very less chance to have the void compared to hand layer and spray layer, and is covered by the vacuum bag, so that reduce the any health safety or the health hazard condition, and the finishing product is very smooth and very good compared to uh, hand layer and the spray layer. The disadvantage of this process is we need to use the skilled person because it's very difficult to create the vacuum. And if once the vacuum is not created and you already inserted the resin towards the system, so that time it will spoil the whole thing. So again, you need to fix the full system. So that's one major disadvantage. The application of this process is a board, like the glass fiber board that is made of by this process. This process vacuum is raised in inclusive method. Race car components like race car bodies are made of the VAR, right? So they have used glass fiber or the carbon fiber, depends upon their requirement. So after the manufacturing, we will be talking about non-destructive testing. There are several inspection method is available, but I have listed few methods that inspect and detect the flow or the damage that is occurred in the laminate or the composite. So entity test, non-destructive test, it can locate or it can measure the flow, length or area, or it can tell you where exactly it can tell you the coordinates sometimes, or where the damage is there. And non-destructive test is not only used for composite material, but also it is applicable for metals, plastic, ceramic, and coatings material. So, so this is the some listed entity test here: visual inspection, radiography, liquid penetrate method, magnetic particles, ED current testing, ultrasonic inspection, and acoustic emission. In this visual inspection method, the damage can be visualized through a microscope or by the naked eyes. So, damage is like form of any cracks or any void that appear on the surface, or any kind of holes, or the delamination on the upper surface, just upper surface. The radiography, this kind of non-destructive testing is used to measure the dimension of the crack that's occurred between the layers of the composite plate. So it will tell the dimension and the location of the damage that time when you are doing this kind of testings. So in this process, this is the probe. It transmits the X-rays. So once it gets the reference, like where the full rays go, and it just comes back again. So if the flow is there or defect is there, it just comes passes through the flow and it just reflect from there, because this kind of process knows this is the final stage. So if we know this whole length here, if we know the whole length, this one here, and if we know this much again length here, so we can easily um, identify where the flows is, because we need to just subtract the coordination of the damage that time. So in this process, it can detect up to 0.5 millimeter dimension, and this process is very hazardous since we are using X-rays. So it's very difficult to use and it's very hazardous. Only skilled people can use this kind of radiography test. This liquid penetrate method. In this testing, we need three kind of spray. The first one is cleaner, and the second is penetrator, and third is developer. So first we need to clean the surface as given here. This is the first part, and the second this is the clean surface. This is a clean surface here, and the third surface we need to apply the penetrate. So penetrate is like basically is a very fluorescent color, either it's red or green, and again after that we need to remove the penetrate of the surface by cloth or any kind of tissue paper. After that, we need to apply the developer. So now the penetrate had tendency to come out when the developer is there. So it's coming out, and after coming out, we can easily identify there is a dent or there is any crack. So one thing again we need to keep in mind, the developer it's very light in color, either it is gray color or the white color, but as other side the fluorescent is very bright in the color or the fluorescent in the color. So this kind of entity method is used for all kind of composite material or all kind of materials except porous material, because the porous material already they have lots of cracks, so we cannot use liquid penetrate method for that. Other than that, it can be used at non-magnetic material or magnetic material. The advantage is very expensive and easy to handle and easy to do. So it does not require any skilled people or any like high skilled to do. So this process is very easy. The magnetic particle. This process is very fast, simple, but the problem with this process is used only for ferromagnetic material, that is iron, nickel, cobalt, and there are few alloys that's made of this materials. So first we need to clean the surface, then apply the magnetic plus there, which will generate, if crack is there, it will generate north and south pole. Then apply the magnetic particle. If the crack is there, it will easily attract those particles there, and that can be seen in the black light because this particle is fluorescent particle. As if it's seen, this crack is there, and this is the green one is magnetic particle. So it's very easy to identify or find where the crack is. And the sixth one, we need to again clean the whole surface to prepare the repair, because once we know the damage is there, we need to do the repair. This again one more entity test, that's ED current testing. This is used for the conductor material. Basically, it's used for the copper or iron, any kind of conductor material. It generates the magnetic field and it's expand as the alternating current raises to maximum and it collapse as the current reduces. So current reduces since there is some crack or any flaws is there. If another electrical conductor brought into the close approximately, the changing magnetic field current will induce the second conductor. That's also one more disadvantage for this whole entity test. So it can detect void, cracks, or change in the change in the grains. If in this place there is some small grains, and in this place there is some big grains, so there is a defect is there because of the size difference. So this kind of testing, this ED current testing is easily identify those kind of defects in the conductor. As I said, like this is the limitation. It's used only for conductor, and it also needs skillful person to do this entity test. Ultrasonic inspection method. In this method, one probe is used. I have done this ultrasonic testing for the carbon fiber. So I know here, and the tank is filled with any kind of medium, either it is oil or it's grease, like the fluid grease or water, and the material or the component of composite component, it should be placed or submerged in the water, and this probe is allowed to move in all three directions, x, y, and the z. So it will give it will take the reference, and it will create like first one kind of photo, that's the software is here. So it's like one kind of photo that's full red, because it's like there is no defect. First it will detect there is no defect, and when you apply the defect identification, then this machine again it will run, and it will it will give you the picture. So the green picture is here, so this is the defect. So this is the experimental part, but basically is based on the principle, it transmit the rays, ultrasonic rays, and again it will go back. So it measures that depth, and if any flaws is there, so it measures that depth also as the reference of the previous one. So this is the full length of going down to the probe, and this is the defect. So based on this, the software works, and it shows you the defect. So this ultrasonic method is not used for porous material, because if any defects or any kind of force is there, that this kind of entity test count there as a damage or as a flaws. So you cannot use this kind of method for the glass fiber, unidirectional glass fiber, or glass fiber. It can use for the carbon fiber, but those carbon fiber is made by the autoclave manufacturing process, because that in that process it provides high heat. It will melt all the resin, and it's uniformly distributed among the fibers and the whole pre-paint. So there is no chance of void or no chance of any defects. So basically ultrasonic is used for the carbon fibers that's made by the autoclave function. This again one more test, acoustic emission test. This kind of entity is used when um, the load is applied to the composite. So it sends the damage. It gives the signal, the sound signal, and based upon that, it gives the signal to the amplifier. Amplifier amplifier is, connect to the acquisition device, and it at the last by the computer, it will show you the defects and the reference point graph. So it's basically like gives the sound wave to the composite when the load is applied. Otherwise, it won't work. So ultrasonic, acoustic emission. Acoustic emission is basically online process. When you apply the load, it will give you the readings. If you don't apply the load, there is no vibration or no defects is there. That's one disadvantage of this process. Another disadvantage is this kind of process is used for the short panel. It does not use for the big panel. At the other side, ultrasonic is used for the big panel too. After the NDT test, the repair of the composites. We need to do the repair because, suppose we are using a composite material for 5 years, and the life of the composite is 10 years. So still 5 more years is remaining in that component. But since it gets damaged, simply we replace it. But if we know that repairable composite material gives another 4 more years or 5 more years, why not we repair that and save the cost, the man cost and the material cost? So for that reason, the repair of the composite is nowadays is very demand. Composite repair has several types. I will state few. Cosmetic repair, resin injection repair, external bounded repair, external bolted patch repair, scarf repair, and truss stepped repair. So in cosmetic repair, this repair is used when the surface has small crack or small holes, the upper surface of any component of the composite. So we can apply just simply resin or any glue to cover up those kind of um, defects. Others, and the second one is resin injection. This kind of repair was used when the defect is lies between the second or the third layer of the composites. But it when the defect it is at the depth of the composite, we cannot use the resin injection. Because it just injects the resin by via syringe. It does not like fully clean the defect area and do the things. So this is also used to do when the defects is lies between the surface or inside the surface, just inside the surface, in first layer or the second layer of the composites. The other method is external bounded repair. This method is like temporary method. This is not permanent method because just we need to make the surface preparation and paste one bonded repair. Just paste one more bond layer. So bond is nothing but the same architecture panel that is used for the parent material. And this kind of repair is able to recover 70 to 100% strength as a parent laminate. If we do like in optimized manner, so we need to make the surface very clean. We need to paste the and the patch is very neatly. So after that, after doing that, it will recover up to 70 to 100%. There is one disadvantage of this patch repair. It did not provide for the thick surface repair. It is for thin repair because if it is thick, it did not hold the patch on the surface. The other repair is external bolted repair. In this repair, the surface has been prepared, so we need to make a hole in the composite, and we'll use a fasten or the nut bolt to fix the patch and the parent material together. So the disadvantage of the external bolted is like we need to make a hole again. So that's create again one more damage hole is there. So the crack will propagate through those holes too. And the another disadvantage is we are using mechanical fastens that made of any iron or any iron alloy or aluminum. So that's also maybe reason of the corrosion. So that's also disadvantage using external bonded repair, bolted repair. And another disadvantage, the weight we are adding to the uh, component. Since we are using the nut and bolt, so we are adding weight to the component, including patch, bolt, washer, and all these small elements come together and add the weight. There's one more disadvantage of using external bolted repair. It does not provide the aerodynamic surface or the smooth surface that is required for the car racing uh, and the aircraft. So For that purpose, we don't use this kind of repair. And other repair is scarf repair. So in this we need this kind of repair is generally used for the aerospace field or the aircraft. So we need to make a scarf at the damaged place or the tapper edge to the damaged place, and we need to make again patch with the scarf angle and the patch, and we need to attach together by glue. So we need to prepare for the surface preparation, and we need to make the scarf. So this is the disadvantage of the scarf repair. Other than that, scarf repair provides smooth surface, and that's very good for the aerospace application. That's like for rocket application and the airplane. So this is the figure, like cosmetic repair when when the defect is at the one ply or the second ply. So I will just select this one ply. Um, this is the resin injection here. So it's like second ply is here, and we'll insert the resin in this part. This is the patch bonded repair. So this is this cut one patch and paste, prepare the surface and paste it the component. This is the mechanical fasten joint. So this one is faster. This is the pad. This is the parent laminate. Again, this is scarf repair. So in this is the parent laminate, and we need to make like scarf and the tapper, as I said, and this is the scarf patch. So we need to make all these two together by using glue or any kind of adhesive material. This is another the same thing of the scarf layer, but it's like step here. So this thing is called flush step repair. So rather than the tapper edge, it has this step here, and since it is a step, the patch also is need to be stepped down. So it's like it has a step. So in the numerical analysis, there are several softwares available in the market to perform numerical analysis. ANSYS, it provides two software, one APDL, another one is another one, I forgot the name, workbench, workbench I think. Yeah, workbench. But workbench did not work with the composite. For that, you need to interface with ACP. If you have ANSYS, you can use ADPL for the composite material. It provides very good result and give very good result with the experimental with your experimental studies also. Then workbench, if you have workbench, you can combine with the ACP, and you can do the analysis of the composite. And there's one more thing. ANSYS, if you want to predict any kind of damage for predictions, not for the experimental analysis, confirmation for prediction, then you need to interface with the MATLAB. So ANSYS supports MATLAB, whereas Abacus support Fortran or VMAT. So if you're using Abacus, you need to you can do work with shell element or continuum shell element. But if you want to use 3D composite material, you need to have at least knowledge of Fortran and how it works. And another is Hypermesh. Hypermesh also works with the composite, and Elastina is post. Elastina also has like two type. One is pre something pre, and the post something post. So the post I forgot name something post. bring it. So those software, the first one gives very good result with the experimental work. And MSc software, MSc software has Nastron. It gives very good result if you want to conduct any kind of agreement with numerical analysis, experimental analysis. And Helios Composite is again another type of software available in the market. The Fiber Sim, this software recently 3 or 4 years ago I discovered, and it's new software, the Fiber Sim. It's good for the if you're using composite material, but it has so many windows inside, so you need to know each and everything. Then you can perform the analysis for this. So this is the experimental and the computational pyramid. So first you need to make a coupon, composite coupon, then you need to do the test. After the test, it's like you need to test. This is a test, and after that you need to make. Yeah. After that you need to have those kind of full structure like T-shape or any kind of sandwich panel, because sandwich panel is nothing but like two laminate is there, and the sandwich that is aluminum foam or anything is between them. So this is the, the first one is laminate, then this is the testing. Then you need to have the component testing after preparing the laminate, then the full panel setting. If you have the structure component, you will have the panel ready. That's go for the testing. This is the full scale test. So this is how the work is going on. The same thing in if you are doing the numerical analysis or the computational analysis. So this is first you need to do micro scale simulation, then you need to use the coupon simulation, the intermediate simulation, and it will go for the panel testing. Then this is the final product. So this in this it's like jet aircraft. On the same again the same thing for the aircraft, and this is for car. Okay, so my
Thank you, Dr.
presentation is
Punita.
finished.
There are some questions I think you will also.
Yeah, I'm seeing those questions. No? It is possible. Let me start from yeah. Which model or method for elasticity approach is most suitable and based to determine composite material properties or material characterization? It depends which kind of damage criteria you wanted to take. So if you wanted to take just fiber damage or like just matrix damage, so I suggest, and if you want to do this shell modeling, not the 3D modeling, then I suggest you there are so many failure criteria available. You can go for it. Then Hashim failure criteria, Schweihoff failure criteria, and there are several 5 or 6 failure criteria is there. I'm not remembering the name. So if you want to use shell element, you can go for it. In the abacus, there is one. If you want to build shell element, you can go for the abacus. There is one inbuilt model for the shell element. If you want to use for just failure criteria, that shows the fiber break and the matrix break. Do we student version for abacus? Yes, we do have the student version for the abacus. If you want to use, you need to go for the abacus website. That's the salt system, and you can check. But student version have a limited amount of meshing element. So it will come with like 100 or 1000 mesh element you can use. But if you want to make the full component, at least you should have 1 lakh or 10 lakhs mesh element. If you want to use student version, you can go there and you can register for the student version. Abacus. But it will ask you your ID, I think. Yeah, it will ask you ID, and after that they will give you Abacus. Then the third one, how to calculate even of the nano filler composite, which formula is used when the filler are used. It's young models, right? Even that's the basic formula. If that's the basic formula if you want to use if you want to calculate the young hardness in the x direction or any one direction, so you can use that formula. I will discuss you if I get time in the next ppt, because I need to cover the numerical analysis again. So maybe can we use hybrid composite for the nose cone for the launch vehicle, which reaches the temperature above 1500 degree centigrade. I don't think you can use those kind of uh, material because it snows, and if it goes at the atmosphere, it will have the impact, because it's like it has a high velocity, and when it goes to the atmosphere, it will have the impact thing, and the nose will just bloom up. So you cannot use hybrid composite. Yeah, but you can use the hybrid composite sandwich material, or you can use the laminates that can withstand with those kind of temperature, and it gives you more impact test in those temperature too. Can you comment on the mechanical properties of natural fibers and synthetic fiber? If you want to use, if you want to calculate the mechanical properties of natural fibers, you need to test your material. Suppose if you are making the sugar can fiber with some kind of resin, so you need to calculate each and everything like E1, E2, and mu also. So for because this is your material, you cannot get those kind of data sheet from the your manufacturer. So you need to calculate everything by yourself if you're using the new material. I'm
Yes,
asking for
I
your
think, yes, I think we are done. Only one question in the chat box is by Mr. Ravi Kumar. Have you told that the detection of the defect in composite is so difficult? Then how would it make to the way to the future development in global market? I think you have answered it in your presentation itself, but some points you can add. Please.
sorry sir, which question?
It's available in the chat box by Mr. Ravi Kumar, not in the Q&A. The
Okay.
chat box. The chat box. His question was: you have told that the detecting the defect in the composite is so difficult. Then how would it would make the way to the future development in global market? I think you have answered it as part of.
It's difficult, but if you have the skilled person, those who has like training hours, that those person have done lots of work on that, like 2 months or 3 months experience. Those people they can detect very easily compared to us. Like we people, we have just 1 week training or like 15 days training. So for
Yes.
them, it's easy, and those people they have experience how to prepare the surface and do every testings. But recently, like if you read more paper, you will get to know like the people they are using ultrasonic testing because it is in very like in current field. People they are using it because it's give you more result also. As I said, like it's give you the location and the size. I think uh, you are. I have answered your question.
Yes, I think it did. And I think
And then,
the other questions can be taken through your profile. If you could share the LinkedIn ID with Ashish, I think some other students are interested to ask more questions. I
yeah,
think
sure.
take it.
I'll send my LinkedIn profile to Ashish. Uh,
I think we can take it offline. I request Dr. K. Vijayaraja, Head of Department of Aeronautical Engineering, to deliver the vote of thanks.
Thanks, Suyash. Good evening, all. I take this opportunity to propose vote of thanks on this occasion of webinar on composite materials and industrial applications. First, I would like to thanks to our director, Madam Dr. Annie Jacob, for her encouragement, motivation, and support to conduct like this webinars through online. On behalf of management and the Department of Aeronautical Engineering, I would like to thanks to today's speaker, Dr. Punita Kumari, Senior Researcher, Wuhan University of Technology, China. Madam, you have explained very enormously about the composite material and application in the aero aviation field. Especially you have mentioned A350, that is 53% of reduction, weight reduction. It may be useful for the fuel consumption. And moreover, apart from this one, regular that new aircraft A380 and some other aircraft, more than 80% of the 80% of material was used by composites. Almost all the parts made out of composite. 80% of the parts are made out of composite materials. And that means all the aero students may know about weight reduction is very, very important in the aviation field. Why? Because means even some amount of weight reduction also is very useful for the fuel accommodation or passenger accommodation or cargo, wherever we are using. Not only you explain about the aviation field, apart from that aero field, you touch about the composite material application in the non-aeronautics field and car industry, sports, cooling towers, and also medical field. The vast application of the composite material in a different field, especially GRPF and thermosetting and thermoplastic. And also you have to explain about the different types of methods used for the windings, spray layout, and how you have to make that composite materials, different types, using the different types, and its application, especially the working principle of the autoclave. And apart from that one, how to find out the how to find out the reduction. Suppose any
damage.
composite materials was cracked or void. For that, you have used the different NDT method. The NDT method is not only in the composite material, all metal parts also we are using. And types of repair methods in composite structures. So you are given enormous and explained very clearly about the composite material and application in the aviation field and the other field also. Thank you, madam. And
Thank you very much,
my
sir.
sincere thanks to Dr. Devasundari, Madam Associate Dean, for your continuous support to conduct like this webinar series. Also, thanks to Mr. Pavan Kumar, Placement Officer, Mr. Nibin Sir, Mr. Venkat, and others directly or indirectly supported for this webinar. Also, I thanks to all the participants. Once again, thanks to all.
Thank you, sir. This is Ashish behind the screen. I'm sorry that he was not able to participate. He was the sole reason for the reason for this webinar. I thank Punita for being with us. There are many projects done by students who needs a lot of guidance in the area of composite. I'm sure the department will be connected with you in future so that we can help the student in a better way. Thank you, Dr. Punita, for joining with
Thank
us.
you very much, sir. Thank you for everyone, for placement professors and for HOD, for all the listeners. And it's very good platform to share the knowledge, whatever I did in the Wuhan, China, and whatever I learned. Thank you very much. It was a very good opportunity for me to share the knowledge. Thank you very much.
Thank you very much.